Question 5 is about resistance and resistivity. And the first thing we have to find is the resistance. So if we are rusty on that, which we shouldn't be if we've been preparing for our exam, but we could look at the data sheet and we see the data sheet as the resistivity formula. Gives it in the form resistivity is RA over L. Well, that's not the form we need, because we know what the resistivity is and we're trying to find the resistance. So we rearrange that formula so that it tells us what resistance is. So to find resistance we need the resistivity, which is given, we need the length, which is given, we need to find the area. Now the area isn't given, it tells you the radius, you've got to calculate the area. And this has made it very easy for you because it's given the radius and it's given it in metres. A more awkward question might slip in the diameter there, and then you'd either automatically use the diameter without thinking, or you have to think very carefully and make sure you use the radius. The other thing that you might be doing, particularly if it was a wire rather than putty, it might give the radius or the diameter in millimetres, and you have to change that into metres. But this is dead straightforward. If I was doing it, I might actually work out the area separately, someone on the side work out the area and then get my answer to put into the equation. And it says that the answer should be given to an appropriate number of significant figures. Well, looking at all the data, 2 figures, 2 figures, 2 figures, so I think it's pretty obvious what the right number of significant figures to use is. Part 2, the putty is reshaped into a cylinder with half the radius and a length which is 4 times as great. That makes it very clear. It says it's reshaped, so it's using the same amount of putty. So you might want just to check that. If you stretch it to be 4 times as long, then common sense must tell you that you've got the same amount of putty, the same volume. So if the length goes up to be 4 times as big, the area must go down to be a quarter of what it was. And of course, if you half the radius and you're squaring it, it does give you a quarter of the area. So that does work. And it asks you to find out how many times greater the resistance is. Well, possibly the safest method is that you knew what the old length was, and you know the new length is 4 times as big. You knew what the old radius was, and the new radius is only half of that. So you could actually go right back to the beginning, use the equation again, and just put the new values in, and that will get you the right answer. But I'm going to show you a method that's more efficient, and it's a skill that comes in all over the place. This idea of thinking about ratios. The original resistance I'm going to call R1. I'm going to call the original length L1 and the original area A1. So R1 equals ρ times L1 over A1. R2, my second value of resistance, is given by resistivity times L2 divided by A2. But we're told how to find L2 and A2 because L2 is for L1 and A2, well, the radius is halved, so that must mean that the area, because you square the radius, it's a half times a half, so the new area is a quarter of the old area. So I've got 4 on the top, I'm dividing by a quarter, well 4 divided by a quarter is 16, so I get 16 ρ L1 over A1. And ρ L1 over A1 is what is the original resistance, R1. So I've shown that the new value of resistance is 16 times the old value. The advantage of this method is that this method using ratios crops up all over the place. If you can manage this, there'll be all sorts of questions you can answer. 5 part B is another one of these questions that people tend to miss out when they're practicing papers and sort of think that because it's just writing you better waffle something in the exam, but it's actually the written questions that make the big difference between the people who get excellent marks and the people who get decent marks in exams. So you've got to describe the experiment you'd do to measure the resistivity. The question told you what the value was, but that's only because somebody at some point must have measured it. So how would you measure it? And it tells you to use a voltmeter, an ammeter and other lab equipment. So you need a circuit diagram. So you're going to be measuring resistance. So you've got to think, in a circuit, how do you connect the ammeter, how do you connect the voltmeter, and draw them correctly connected. Are you just going to use a fixed power supply, or are you going to use a variable power supply that lets you use different currents and different voltages? What are you going to measure? How many measurements are you going to take? Are you just going to use one voltage and get one measurement of current? Or are you going to do different voltages, get a different measure of current, and draw a graph? Is that a good way of finding resistance of something? How are you going to use your measurements? How will you use the measurements for the apparatus to find resistance? How will you use the measurements for resistance to find resistivity? And what about precision? What instruments will you use to measure the dimensions of the sample, its radius and its length? How will you take those measurements? Will you just measure in one place? Will you measure it several places? Will you measure once? Will you measure several times? So those are all the points that marks are available for. And it also needs to be written in good English as well to get full marks.